Natural Language Processing and Electronic Medical Record Systems by Shaunice Miller. What is EMR? EMR stands for Electronic Medical Records. It is a highly complex, interactive technological device. Essentially, it's a database system that entails patient records and history, using its most basic function of entering either through free text or speech and the semi-automatic maintenance of patient records into its system. EMRs are used within healthcare environments. It is used for decision support by medical professionals. This specific type of interface database is used by physicians in hopes to make more educated medical decisions for their patients. It is also used for its ability to handle data pertaining to specific patients and interpret it as knowledge from those records. The database will then generate assessments based on specific patient needs extracted from submitted patient histories using NLP, which is also known as natural language processing. The database will then suggest recommendations to the physician for them to consider for future applications to that patient. What is NLP? NLP stands for Natural Language Processing. It is an information retrieval tool used to data mine for specific information and then to extract accordingly based on user needs. It provides huge benefits in decision to support usage. Natural language processing is the analysis of free text and/or speech. Its main concern is handling the interactions between a computer and the human user's natural language. NLP utilizes its ability to capture and interpret unstructured data in the form of natural language and transform that information into structured machine-readable information based on that user's medical-related needs. How it works. Natural Language Interface to Database Systems, or NLIDBs, are made up of two subcomponents. These subcomponents allow for the communication between the user and the computer to occur. The first subcomponent relates to linguistics. It is liable for the translation of the user's natural language into a formal query for the system to understand. Using syntax analyzers, it will generate a response in the form of natural language based on query results. The second subcomponent is the database itself. Here it allows traditional database functionality after the natural language has been configured into a standard query language and will produce results accordingly. These results are structured within query language until it's passed back through the linguistic component, which provide a result via natural language. NLP applications can be formatted into two specific types: active natural language processing and passive natural language processing. Passive NLPs requires the user to manually input data into the EMR system. This will be able to generate some sort of output that is readable. Active NLPs take already existing information within the system and then extracts patient-specific information and generates an output to the user. The information within the system is then broken down into different processing levels for the system to comprehend before extraction. There are 4 levels of document processing, and they are lexical, syntax, semantic, and discourse. Each processing level, previously mentioned, breaks down the document into different forms of granularity. Lexical processing breaks down words into morphemes, or is also known as word segmentation, through the use of morphological analysis. At this level, linguistic patterns are articulated in a way so that computers will know the beginning and ends of the words being analyzed. This will allow the system to maximize its results within patient records when searching and retrieving information. Within the syntax level, it is used to analyze the structure of a sentence. It evaluates the sequences of words within the sentence and shows grammatical relationships. The syntax level process will determine the appropriate context for the specific term in a sentence and will interpret the meaning accordingly. The semantic level provides meaning to words. Using the semantic analysis, it provides a systematic structure of a sentence and configures the meaning based on context. The discourse level applies context to a sentence. The system will take a sentence from a document and relate it to the ones that come before and after it. This will establish meaningful contextual relationships among sentences within the document. Statistical probabilistic approaches, or symbolic grammar-based approaches, NLPs aim to lessen the gap between the varying levels of patterns of word usages found within documents. The statistic approach uses statistical processing to examine the frequency and weight of word usages. This means it'll find the statistic likelihood of words that were used within a single document. It'll be able to pinpoint main topics within the text based on the assumption that the most recurrent words used within the text are keywords or are pertaining to main themes within that document. The grammar-based approach is designed to seek patterns not only in words but within sentences as well. It is used to distinguish differences in word usage found within the record. Reasons for use. EMRs are being implemented within medical settings for its ability to aid in the vast inaccuracies found within paper-based records. These paper-based records are highly susceptible to human error, thus causing a great concern for patients. EMR systems provide an effective way to transcribe information in a more effective and safer method. EMR systems are used to track data over time, identify patients who are overdue for preventative medical procedures, monitor its patients, improve patient care within a practice, and alert physicians when specific medical situations arise. EMRs provide a public health benefit to its patients by decreasing medication errors, increasing adherence to medical guidelines, and easing tensions relating to medication ordering. EMR systems are simple and easy to use. It doesn't require training, and it doesn't require an artificial language, since it uses the natural language of that user to retrieve information. The system is also highly expressive, permits a variety of access points, it is highly flexible, it is highly representative of reality, it represents any and all main points of view, it is easy to represent new and complex concepts, and it allows freedom of expression. Drawbacks to using natural language processing systems. When using NLPs, it is very difficult to make generic searches. It also has a problem with deciphering synonyms, homographs, as well as ambiguous or fuzzy concepts. It is not standardized and it isn't very compact. Another disadvantage to using this type of system is that the user must think of their own search terms. Since NLPs have a limited natural language data set, it finds trouble determining semantics in the extracted information pulled from records. NLPs are also unsuitable within clinical settings. NLPs makes it hard to share and collaborate data among researchers. It lacks in its ability to provide a way to have reliable de-identification methodology. Without a proper de-identification technique, sensitive information being extracted from these patient records would be available to all, thus breaching patient confidentiality. Drawbacks to using EMR. Initial adoption of EMR systems within medical settings has been slow due to culture, costs, and confusion. Most physicians are already set in their ways when using paper-based methodologies to inscribe patient information. Because EMRs are a new technology, there are various types of systems out there. The mass availability of these machines has caused mass confusion for its consumers. Due to the mass amount of systems that are available, prices are varying for each system. Not only do medical facilities have to buy the system, they also have to implement and install it throughout their facilities, maintain its functionality, and license these devices. These all affect the cost of buying an EMR system. Another drawback to using an EMR system is that it is very time-consuming to implement this technology within a medical setting. EMRs are also susceptible to system failures, which can create mass confusion for its users. Future applications of EMRs. Future usages of these systems are already underway. Research is being conducted to handle improved filtering and alerting techniques, to find faster, more accurate data mining and entity extraction methods, cross-language retrieval, extraction speed, automated summarization methods, and even machine-aided indexing. These advancements in technology will lead to more effective NLPs and can help re-revolutionize EMR systems within the medical world.